So this algebra lesson looks at the multiplication of algebraic fractions. Algebraic fractions are multiplied the same way you multiply numeric fractions. You multiply straight across. Let's illustrate this. What if we want to do 2/4 times 3/5? So I would have 2 of the 4 rows being shaded. I would have 3 of the 5 rows being shaded. And I would only fill that in, which would be 6 squares out of 20. And so you'll notice what happened. I did 2 times 3, and I did 4 times 5, and I got 6 divided by 20. So the multiplying fractions property says for all real numbers, a, b, c, and d, and b and d cannot be 0, a over b times c over d equals ac over bd. Let's look at an example of L over 4 times W over 3. If you use the property, you're simply multiplying straight across, and so you get LW divided by 12. You can always check these by substituting values for L and W. Let's say L is 20 and W is 8. So 20 over 4 times 8 over 3. That, of course, equals the same thing. 40 over 3 equals 40 over 3. Now, what about equivalent expressions here? Because the fraction LW over 12 is another way of writing 1/12 LW. I could prove that each of the following expressions equals 5x over 3. 5/3 x is the same as 5 over 3 times x over 1, which is 5x over 3. 1/3 times 5x equals 1 over 3 times 5x over 1 is 5x over 3. And 5 times x over 3 equals 5 over 1 times x over 3, which equals 5x over 3. So each of those three is equal to the original of 5x over 3. This shows that they are all equal to each other. The first one is the best, 5x over 3. No multiplication symbols and one fraction. That's always what you're looking for. So every numerical fraction is equal to many other fractions. So 3/5 equals 30 over 50, 30 over 50 equals 9/15. These are all examples of the equal fractions property. The reason why I'm showing you this is because you'll have to sometimes simplify a fraction to lowest terms. And so dividing by the same number top and bottom or multiplying by the same number top bottom will always get you an equal fraction. So if I have 112 AB divided by 7A, I could simplify this by looking at, are there any numbers that can go into 112 and 7? So that's what we're going to look at. So you can see what happens here. Basically, the 112 becomes 16, 7 becomes 1, and you're left with 16b. So here are some examples. You can just do a couple of them. We're not going to do all of them. Let's start with 5ab over 10b. So 1/2 a, your b's are going to cancel, so the best answer is going to be a divided by 2. What about 27x squared over 9x squared? Well, you have x squared and x squared, those are going to cancel. It's a matter of doing 27 divided by 9. So that equals 3. So that's 1 and 2. What I would do is 3 through 6, get some answers down for 3 through 6, pause this video, and then I'll put up the answers here, and you can see how you did. So here are the answers. You can see how you did with 3 through 6. We have 1 over z. Number 4 should be 8d over a. Number 5 should be 2m over 3. And number 6 should be 4 pi divided by x. Let's take a look at this example. We have 4x over 27y times 3y over 2x squared. So what I'm going to do is multiply straight across, and I'm going to get 12xy divided by 54x squared y. And what happens is I'm going to look at my 12 and my 54, and I'm going to see, alright, are there any numbers that go into both 54 and 12? And the answer is yes. 6 goes in here. I'm going to cross that out and write 2 and 9. My y's are going to cancel. This x is going to cancel with one of my x's down there. So I'm left with 2 divided by 9x. That's going to be my final answer. So here are some other examples that you can try. What I would recommend doing is multiply everything straight across, then try to reduce any numbers that you get, and then just break it down and see what variables you're left with. And then when you're finished, just pick a value for the variable. So for that first one there, pick a value for n, check your original and check your final, and the value should match. It gets a little bit more difficult for the other examples when you have multiple variables, but it still works just the same. Check those, see how you do, use the property, and that's it. Thanks for watching.